In our previous example, we used chops to build a jiggle deformer to modify our points on a point level. And so in this chapter, what we're going to do is, or this section rather, what we're going to do is just use motion effects and chops to generate some procedural animation for us. So let's do that to a sphere. Let's throw it on a sphere. And I'm just going to jump inside the sphere and throw down a transform. And this transform is where we're going to add our procedural animation. We just want to create a little bit of a random noisy movement for our sphere to bounce around. So I'm going to do that by going up to selecting my transform, and then going up to the translate, right clicking, and then going down to this motion effects. And you see the motion effects pop out and gives you all sorts of little options for getting started here. So you could do something like you could lag the motion, shift, smooth, spray, all this stuff. What we could do is throw down, let's do a noise. And you can see this window pops up, and this is our motion effects view. It looks a lot like our graph editor, actually. And really what it is showing us the graphs that are being generated by our noise functions in chops. And this basically acts as a takeover on our animation curve. So when I play this back, our sphere is moving all over the place. I'm just going to click the real-time toggle so this plays back at 24 frames per second so I can see what's going on. So I don't necessarily want this motion effects view to be hovering, so I'm going to get rid of that. Now, I don't necessarily want this motion effects view hovering, so I'm going to just close it, and then I'm going to reopen it by hitting Alt right square bracket, like so. That just, with my mouse hovering over this view, is the same as going up in this corner and saying split pane top bottom. So it's an Alt right bracket, it's a little hint there. And then I'm going to go over here to the scene view tab, right click, and choose motion effects view. And now we're back to where we were just a second ago with that floating window. So now let's just back up a second. We've got our motion effects network that's been created right here. If I hop up to the sphere, you can see that it has dropped down a chop network in our network right next to the thing that we're modifying. So if I look back at my transform now, you can see that the translate has values in it, and it's got these little yellow squares to the side. These just mean that it's being overwritten by something in this chop net. So if I jump into this chop net, like so, you can see on this first one, this channel chop is actually is fetching the transform1 translate parameter, and it's a 3 float parameter. You know, that is 3 floats for each of our translate X, Y, and Z values. So back into chops, it's bringing this in, and then we're just adding to that value, whatever value it originally was. What we're going to add to that value is this noise function that's being created. And because we've got this display flag set down here, we can see what this display flag right here is showing the final position as it's being modified by the noise. Now I could, if I set the display flag up here, it's just flat because there's no movement on it whatsoever until we do something to it. So once we add this noise to it, so if I just set the display flag on the noise only, you can see the noise, and because the noise is being added to whatever it was before, which is 0, we can just you can see that it's just taking on that. If we actually go back over here to the noise, we get these nice little handles that we can use to modify the shape of the noise. And if you look up here in the parameters view, when I'm moving this, it's actually affecting the period, which is essentially bringing us a lower frequency noise. So when I play this back, you can see that it's moving a little bit slower. Now, not every parameter up here is visible in the motion effects view down here, but I just thought that was kind of cool to show. So we could actually bring down maybe the roughness, and you can see it modifying the position and our graph as well down here. So we get like a little bit smoother of a motion. Maybe I'll bring the period down a little bit and just bring the roughness down so that it has a really smooth movement, but it's still fast, but not super jittery like this where it's bouncing all over the place. So just bring the motion or the roughness down to something like that. Cool. So now we've got our sphere kind of bouncing around. I want to give it just a little bit more amplitude. You can see that it's, if we look at our graph here, we have an amplitude set of 10, and it's not fully achieving an amplitude of 10. And that's probably because we've brought the roughness down. If we were to increase that, you could see that it is actually maxing out at 10 just because, but bringing that roughness down, it doesn't fully reach that, those heights. But what we could do is you could just continue to increase our amplitude. And what I want to do is maybe use this behavior to, kind of create the effect of like a little, almost like a creature trying to break out of a box. So, just like a little random sphere that's just bouncing around inside of a box and trying to escape. So if I go up here to our SOP level inside our sphere and just throw it in a box for reference, I'll make the box, let's scale it up. Oops. Yeah, let's scale it up by 10. So its maximum value is 5. Just hit spacebar 2 to switch to the top view. And I want to just pin this view so that when we're in our ChopNet, we can actually still see our little box template that we've selected here. So inside motion effects now, if I were to crank this amplitude up higher, you can see that the sphere is actually escaping out of the box quite a bit. But what we can do is we can actually modify these noises and, modify them as we would like SOPs. So in SOPs, if we're modifying points in space and modifying attributes and using attributes to derive the positions of points in space and other attributes on those points, Chops is much the same way, except we're modifying signals like this noise that's down here. So we could modify this by clamping the motion of this sphere to stay within the box. So let's throw down a limit. So this limit, I can just throw this in right after the noise, and if I turn the display flag off on the noise and turn the display flag on the limit, you can see really it's basically the same as what we had because it's set to off. So I'm just going to turn this on and set it to clamp. And you can see now that by default, it's clamped to a minimum and maximum of 1. And if you look at the numbers on the side of our graph here, you can see, yeah, if this is 2, it's maxing out at halfway between there, so that's 1. I'm just going to hit stop so that I can access these parameters. I want to set the minimum to, if our box goes from -5 to +5, we're going to want this minimum to go from -5 to +5 as well. So now we can see that our noise, our sphere is moving around inside of our box, and then occasionally it hits these walls, which it gets kind of limited by. So if I play that back, you can see that the sphere never really leaves the box. But now, because the sphere has a little bit of radius, and this calculation is actually happening based off of the center of the sphere, we could actually reduce this clamping range a little bit to compensate for it. So it really feels like the sphere is staying inside the box. So if we go back up to the sphere network and we look at our sphere, we can see that the sphere has a radius of 1. So we can use that radius as sort of what determines this limit. So maybe I can just go up here and let's just go to the sphere, and we're going to grab the first radius because we're going to keep it uniform. I'm going to say copy parameter, go into our motion effects view to our limit, and I'm going to say maximum. I'm going to say the maximum is 5 minus paste relative references. So that brings it down a little bit to 4, which is cool. And then over here, we're just going to make this the negative of whatever our maximum is. So I'm going to copy this parameter, go up here and paste relative references, and just switch that to negative. So now when we when our sphere is bouncing around in here, it's actually staying limited to within the box. And again, you could even make this even more procedural, such as changing the changing this max value to read whatever the maximum amount of your box is using the bounding box function if you wanted. So I'm not going to go that far with it, but let's just hit spacebar 1 to get back out here, and we can see. Oops, I accidentally, when I was using my commands, I ended up overwriting that value of 5 and putting in spacebar 1 and spacebar 2 as I was frantically trying to remember those keyboard combinations. So I'm just going to hit 5 to get that back in order where it is trying to escape the box, but it can't. So this would be good if you wanted to, like, maybe, I don't know, create a fly or something like that in a room, but the possibilities are they go much deeper than just simply this. For example, you could bring in a wave if you wanted to control the motion of the of your sphere. So I'm just gonna highlight this wave, and you can see this wave is a sine wave, and it is affecting all 3 channels at once, but it's giving you this little zigzag pattern. So there's that. You can increase the amplitudes and modify all this stuff sort of in here or up here, but it goes even further than that. You can bring in audio. You could bring in you could actually record yourself. So if I put down a recorder and audio input, I could actually set this audio in to recognize my voice from my microphone. So with the audio in node selected, what I'll do is I'll just highlight it. And I got line selected. That's good. I just want to go to my channel here, and its sample rate is set to 24. That's for 24 frames a second. We actually, for audio, what CD quality generally is 44,100 samples per second. So I'm just going to type that in, 44100. Leftover from my days as an audio expert. So now this is sampling at 44,100. Now, if I hit, I'm going to just disconnect this by holding down Y and slashing through it, because I just want to view this audio, what this audio is doing right here. So I'm just going to hit play. And you can see that as it goes, that it is doing a little bit of, you can see a little bit of vibration happening here as I'm talking. So that's a good sign. I'm going to just, let's bring it into our recorder now. So this audio in is reading from my line source, and I have this set in my my audio settings. So for example, manage audio devices. Here I've got on recording my line in from my Steinberg setup. So you just want to make sure that your microphone is set to whatever line in is, and then it should recognize that up here. So let's just do this. I'm going to wire the audio in to the record, and I'm going to highlight the record and then disconnect I can leave these both displaying right now. So now on record, it is set to record on. So whenever I hit play, it's going to record what's coming from the audio in. So let's do that. This is me recording some audio into Houdini so that we can make some procedural animations. And I'm going to stop. So if I now play that back, if I play that back now, this is dangerous. It's set to record still. So if I go back to like frame 1 or something and start recording, it's going to actually start recording over what I just did. So I'm just going to turn that recording to off. We can zoom in a little bit here. I'm just, again, zooming in by holding down Alt and right clicking and dragging vertically and horizontally while holding down my right mouse button. So you can see we've got this audio that we've recorded here. I'm turning the recording to off so I'm not overwriting it. And then I want to hear it in my timeline. So I'm just going to hit this little speaker icon down in the corner here. That brings up this window. If I go to Scrub and then select a chop, I'm going to just say, I'm going to put down a null and just call this to player. And what I'll do is just drag this right in here. And now anything that's plugged into my 2-player null will play back on the timeline. You can see it's down here on the timeline. Cool. So let me just close this and let's hit play. This is me recording some audio into Houdini so that we can make some procedural animations. Cool. Sorry, my apologies for the lame recording. I'm just making this up as I go. At any rate, so we've got this audio that we've brought in. That's awesome. So now what could I do with this? Let's see. If I were to go, let's just maybe drive the scale of this object. I'm going to see if I can get this set up from scratch here. So let's see what happened here. In here, we grabbed a channel grabbed the T channel. So if I hop up here to our transform and I hover over translate, you can see that the parameters are TX, TY, and TZ. So if I go to uniform scale, you can see that this parameter is called scale. So let's try to mimic this. I'm just going to create a channel. And I'm just going to kind of copy what happened over here. So over here, look for transform 1 colon T. I'm going to copy that. I'm going to go over here and paste it, but I'm going to put in scale instead. So what that could do is actually export to our scale parameter on that transform. So let's see what we have here. If I go back up to our transform, you can see it is now being overridden. And if I change this value, if you just go to something like, we'll just change this to 1, then we should be adding to it when we add in our motion effects. So let me just add to it with our sine wave just to make sure that it's actually doing something. So I have this set to the output now. Got our wave here, and let's hit playback. And you can see that it is actually it's actually changing the scale of our object according to whatever this wave is doing. So if I decrease the amplitude, it should probably not scale into the negative. This is me so that's cool. And you can probably hear me at the same time as I play this back. Sorry about that. But yeah, this is definitely working the way I thought it would. So that's sort of your guide. You look at what sort of Houdini automatically does for you, and you just kind of dissect it, and then you can sort of repurpose it and reverse engineer it for yourself. So cool. So now let's try and get this audio to do something to our sphere. So maybe instead of the wave, what we'll do is we'll just wire in this recording that we did. So I'm going to just I'm going to flip back over here, and let's just play this down again. If we go back, it's a good sound play. This is me recording some audio into Houdini so that we can make some procedure. Cool. So you can see that it's actually moving. Play. This is me recording some audio, and you can see it's moving this sphere around, but it's very erratic behavior. That's because this is a very high frequency noise relative to what our frame rate is, and it's also crossing into the negative and everything like that, and giving us very erratic type like behavior. So what we could do is we could throw down something like an envelope. Just going to throw that down. An envelope is going to analyze what the maximum levels are of our wave, and this try and give us like a generalized form of it that isn't zigzagging, back and forth across the 0 so much, but rather just giving us a value that increases away from 0 in the positive, so that we can just scale this up positively and then add that scale to our noise. So now if I turn off the audio in, and let's look at this. So yeah, you can see that it's working at a sample rate of 24. That's good. I'm just dialing this around to see if that changes anything. Okay. Yeah, we want this sample rate to be at 24, I believe, but I just want to. Oh yeah, we can actually resample this. Yeah, that's good. So now what I can do is because the envelope is resampling, we can now kind of like add as much detail as we want to it. I think that basically because this recording happened at 44.1 and this audio signal is coming in at here at 44 1100. This envelope is, you know, running at that rate too until we resample it. This is much like resampling points in SOPs on curves or something like to that effect. So if I resample this, I can sort of generate my own amount of my own level of detail for this motion. So you can see we've got now like a nice simple curve. If I turn off the recording, we've got this nice simple curve that's sort of following along with our with the amplitude of our dialogue that we recorded. So now when I click play, its motion should be much more legible. It's a good sign. Play. This is me recording some audio into Houdini so that we can make some procedural animations. It's still a little drastic. I guess maybe I could actually fully resample this back down to 24 to see if it gives us a much like a more legible curve. So let's just bring that back to 24 since that's what we're landing on anyways. And I'll just play that again. It's a good sign. Play. This is me recording some audio into Houdini so that we can make some procedural animations. Okay, cool. And let's see if I can smooth that out a little bit. So now we've got this sort of zigzaggy like behavior. What we could do is we could just let's just throw down a filter and see how that works. So if I throw down this filter, having resampled this back to 24, this filter is actually going to look at all these values and sort of try and average them. It's sort of doing like a Gaussian blur to this waveform, which is cool. So with both these displays up, you can kind of see it wiggling through like more or less like an average of what's going on with this wave. So if I bring this filter width down, you can see that it approaches, it comes closer to what the original was as I dial it in and away. So I'm going to just, let's see if I can, let's just try something like a filter of that. I don't know what the effect does. Yeah, the effect is just more or less the effect strength right here. So if I had like a very loose, a very wide filter, and then I were to dial this effect back, it's basically just mixing between the two. So let's just leave our filter with something like this for right now and see what this looks like when we play it back. And it's a good sign. Play. This is me recording some audio into Houdini so that we can make some procedural animations. You can see that it's much slower. I'm just going to bring out, I don't want to listen to the front end of that. I'm just going to grab this frame range and just kind of isolate our waveform right here. And so I'm going to, let's just try and dial this in a little bit more. So I'm just going to, I want to bring the filter width down slightly. And maybe what I can do is, let's see. Yeah, let's see how that works. I'm going to actually maybe just increase the amplitude of the original recording. So maybe what I could do is, let's see if I've got, is there, I'm trying to see, yeah, there's a gain here. So if I take gain A up, I'm not sure if this is actually going to change anything because this is actually already recorded. So let me go to, let's just add, I'm going to go in here and look at, let's see if I can do I'll create a constant like so. And then maybe I can do a multiply. Will that work? Let's shake that off. Multiply. I'm trying to see if I can multiply this recording's value by some constant to increase its value. So that looks like it's working. Let's see if I can multiply it by, let's say 2. So now we have a much larger amplitude. And I think that it's actually going to be a little bit slow because it's processing at 44.1. So I'm going to actually bring this in after the envelope. Just going to grab this, shake that off and bring it down here and wire back in our constant. So you can see we're increasing the volume of our our amplitude significantly here. So I think what I want to do at this point is maybe make it so that these valleys kind of fall after our envelope. These filtered valleys kind of fall a little bit deeper and actually bottom out, on our thing here. So what I can do is I can actually just subtract some value from this signal. So I'm just going to throw down, let's just throw down another constant. Let's throw down constant like this, and we're going to throw down another math, and we're just going to take whatever is coming out of our filter, and I'm just going to subtract something from it. We're just going to bring on our math node, I'm going to select the combine channels to be subtract. If I show this, and then I'm going to bring, let's see, let me just check my noise. Combine chops is set to add, so I don't want my channels to be subtracted. I'm going to set that back to off, and combine chops is going to be set to subtract. So now on my constant, I can decrease this value, and you can see when I decrease this, or when I add some value here, it's actually starting to let's just increase the size here. It's actually starting to drop this signal below 0 a little bit. So I can bring this signal down below 0. So now I've got this sort of like 0 is occurring right here. And then if I pass this through another limit and I clamp the bottom to 0, and then set the display flag here, turn off the math node, you can see that now my the audio is actually bottoming out. So what we had before was it was crossing below 0. Now we're limiting it so that it can't cross below 0, but it's effectively allowed us to like kind of get rid of some of these this amplitude that's just sort of hovering here and just like dropping it down so we can actually create some more peaks for ourselves. So while I'm focusing on this limit right here, what I want to do is just sort of grab my constant. I can, if I grab this and start to like increase this constant value, you can see it's subtracting more and more of my audio waveform away and causing it to drop below, but then it's clamped off by this limit, so we can actually like kind of build some nice little valleys for ourselves like so we can have our scale kind of hit on the peaks that we want. We're sort of starting to isolate the pieces of audio that we had. And you can see we started with this, and now we've created this new signal based off of it, which is really powerful. So let's see what our animation sounds like now. Our player, there's nothing hooked up to our player, so I'm going to wire the recording back into our player so that we can see what our animation looks like now that we were able to apply some of these filters to it. You can kind of see our initial recording here. This is our original in blue, and this is what we've managed to extract from that in green. Now let's see what it's like to play this back. So I'm going to just, if your player became disconnected, mine did in the previous take. If your players become disconnected, just make sure to set it back up to connect to your recording. Otherwise, it'll sound weird. I don't think it'll really generate anything useful in terms of sound if you plug it into anything other than the recording at this point. So you can see that the my waveform's down here on the bottom, and I'm just going to hit play to see what we get for animation now. This is me recording some audio into Houdini so that we can make some procedural animations. This is me recording some audio into Houdini so that we can make some Cool. So it seems like it is doing the thing. That's great. I do notice that it is kind of falling off a little bit at the end. You could continue to tweak this to your heart's content, but that's just sort of an intro to what some of the workflows are like in Chops when you're using it to manipulate signals to generate procedural animation. Very powerful stuff. And that kind of wraps it for this chapter. So those first two examples really covered chops, and that is one section that I think is really important to just touch on. And then in the next section, we're going to actually talk about COPs, or compositing operations. Believe it or not, there's an entire node-based compositing system hidden inside of Houdini that we can unlock and use in a way that would remind you a lot like Substance Designer. That's just one of the uses for it, which we're going to cover, but it's going to give you an idea of what kind of power is hidden inside of Houdini when you're using a compositing based app to help build your shaders. So we're going to cover that in the next chapter. I think it's a pretty sweet workflow, so go check it out, and I'll see you in the next lesson.